A sphere of mass m is moving with velocity v, and there is another sphere which is of mass m and stationary. It is given that coefficient of restitution between these two is e. We need to find the ratio of velocities after the collision. So let after the collision, this be the situation. This is A, this is B, this is A, this is B. Let velocity of A be v1, velocity of B be v2. This is of mass m, this is of mass m. We have coefficient of restitution as velocity of separation by velocity of approach. Velocity of separation by velocity of approach. So let v1 and v2 be in these directions. If they are opposite, then we will get v1 and v2 as negative. So it won't make any problem. So E equals to v2 minus v1 by v minus 0. This is velocity of separation, this is velocity of approach. Velocity of approach. So this equals to v2 minus v1 by v. From this we get v2 minus v1 is equals to e times v. Let this be first equation. Using conservation of linear momentum, we can write mv plus m into 0 is equals to mv1 plus mv2. From this, v1 plus v2 is equals to v. Let this be second equation. One plus two implies two times v2 is equals to ev plus v. Minus 1 plus 2 implies 2 times v3 is equals to minus ev plus v. From this, v2 by v3 is equals to 1 plus e by 1 minus e. See this carefully, this is minus 1 plus 2, that is 2 minus 1. So from this we get this equation, and from this we get this equation. So by taking ratios we get 1 plus e by 1 minus e as the ratio of velocities after the collision.